Imagine walking into a supermarket, almost anywhere on Earth. On the shelves, you will probably find them. Small packets, plastic cups, paper bowls, dozens of flavors, colors, shapes, and price points. Instant noodles may look simple. Open the package, add boiling water, wait a few minutes, and dinner is ready. But behind that simple experience is an industrial process involving precision mixing, high-speed rolling, cutting, steaming, drying, seasoning, packaging, and continuous quality control. And the scale is enormous. According to the World Instant Noodles Association, global demand remains above 100 billion servings a year, with major markets spread across Asia, North America, and other regions. In 2025 alone, China and Hong Kong accounted for more than 43 billion servings, Indonesia for more than 14.5 billion, India for more than 9.6 billion, Japan for nearly 6 billion, and the United States for more than 5.2 billion. So how does an ordinary-looking package become part of a global food system operating at this scale? The answer begins with something surprisingly basic: flour. In a typical production facility, wheat flour is combined with water, salt, and other permitted ingredients according to a carefully controlled formula. The exact recipe varies by manufacturer and product. Some noodles are designed to be springy and firm. Others are softer. Some are intended for frying, while others are produced using hot air drying. The first objective is always the same: create a dough with a predictable structure. Large industrial mixers can process hundreds of kilograms of ingredients at a time. Inside the mixer, rotating blades continuously fold and compress the flour, while water is distributed throughout the mixture. At first, the ingredients may look dry and disconnected. Then, gradually, they become a single mass. The dough is not ready to become noodles yet. It needs time. After mixing, the dough is allowed to rest. This gives the flour and gluten network time to stabilize, helping the dough become easier to process and giving the finished noodles the characteristic elasticity consumers expect. Then, the dough moves toward one of the most visually impressive stages of the entire factory: the rolling line. Imagine a thick block of dough entering between enormous steel rollers. The rollers squeeze it. Then another set squeezes it again, and again. With every pass, the dough becomes thinner, wider, and more uniform. What began as a heavy mass gradually transforms into a continuous sheet. This stage is far more important than simply making the dough thin. The mechanical action also helps develop a consistent internal structure. Thickness must be controlled carefully because even small variations can affect cooking time, texture, and the way the noodles absorb water later. Eventually, the sheet reaches the cutting system, and this is where the flat sheet suddenly becomes what we recognize as noodles.
High-speed cutting rollers fitted with specialized blades slice the dough into hundreds of narrow strands. The machine is moving quickly, but precision is critical. Every strand needs to remain within a specified width. The noodles now travel continuously along the conveyor system, but they still aren't ready to be packaged. They need heat, and they need structure. The next stage is steaming. Before entering the steaming chamber, the strands may be exposed to hot water or moisture to prepare the surface and help regulate hydration. Then they enter a chamber filled with hot steam. Inside, heat penetrates the strands and partially gelatinizes the starch. This step is one of the keys to the familiar instant noodle texture. The noodle has to be cooked enough to transform its structure, but it must also retain the ability to absorb water and become ready to eat later. This is one of the great engineering tricks behind instant noodles. The factory is not simply cooking pasta and drying it. It is creating a noodle that can effectively pause its cooking process and resume it when a consumer adds boiling water. Once steaming is complete, the continuous sheet of noodles is divided into individual portions. Automated cutting systems measure the length and weight. Then, forming machines arrange each portion into a compact noodle cake. Depending on the product, that cake may be square, rectangular, or round. At this point, the noodles look almost ready. There is still one critical transformation left. Water has to come out. And the way manufacturers remove that water helps determine how quickly the noodle will rehydrate later. That takes us to the drying stage. There are two major approaches used in instant noodle production. The noodles may be dried by frying them in hot oil, or they may be dried using hot air. Both methods are designed to dramatically reduce moisture and create a porous internal structure. Why is that important? Because the consumer will eventually do the opposite. The factory takes water out. The consumer puts water back in. During drying, tiny spaces are created within the noodle structure. When boiling water is added later, water can rapidly move into those spaces. That is why a noodle that has been stored dry for months can become soft and edible within minutes. It is a remarkable example of food engineering hiding behind an ordinary product. The drying stage also helps create a product that can be stored for long periods under appropriate packaging and storage conditions. But there is another half of the instant noodle experience. Arguably, it is the part consumers remember most: the flavor. The noodle provides the texture. The seasoning provides the identity. Behind a small seasoning packet can be an unexpectedly complex manufacturing process.
Depending on the product, manufacturers may use spices, dehydrated vegetables, meat-derived ingredients, oils, sauces, flavorings, and other ingredients. Some products contain several separate components: a powder packet, concentrated sauce, an oil packet, dried vegetables, sometimes more. The ingredients are inspected and processed before they enter production. Vegetables such as carrots, cabbage, green onions, mushrooms, or other ingredients may be cleaned, cut, and dehydrated. The objective is to remove most of their moisture while preserving as much of their characteristic flavor, appearance, and functionality as practical. Why dehydrate vegetables? Because fresh vegetables contain large amounts of water. That water creates a major challenge for long-term storage. Remove most of it, and the ingredient becomes much more stable. When the consumer later adds boiling water, the dried vegetables absorb moisture again. They expand. Their texture returns. And suddenly, what looked like tiny dry flakes becomes recognizable food in the bowl. Flavor concentrates can follow a different path. Ingredients may be cooked in large industrial vessels under controlled conditions. Depending on the formulation, cooking can extract flavor compounds from meat, vegetables, spices, aromatics, and other ingredients. The liquid can then be filtered. Unwanted particles are removed. The remaining broth or sauce may be concentrated, reducing excess water and increasing the intensity of the flavor. This is where industrial food production becomes especially interesting. The final seasoning may only occupy a small fraction of the package, but producing it can require multiple stages of cooking, filtration, concentration, cooling, drying, and precise dosing. And consistency matters. A consumer expects the same product to taste recognizable, whether the package is opened in Tokyo, Los Angeles, London, Jakarta, or another part of the world. That means every ingredient has to be measured carefully. Temperature has to be controlled. Moisture has to be monitored. Processing times have to be standardized. And the final product has to meet food safety requirements. International standards also exist for instant noodles. The Codex Alimentarius system, maintained by FAO and WHO, includes a specific standard for instant noodles, reflecting the fact that this is now a globally traded food category rather than a local specialty. Once the seasoning components are finished, they move toward automated packaging. The finished package may look completely ordinary, but in reality, it is the final product of a chain of carefully controlled processes. And the factory is not finished yet. Before anything leaves the facility, it has to pass inspection. Now imagine the packaging line moving continuously, one noodle cake after another.
One seasoning packet after another. One package after another. At high production volumes, human workers cannot manually inspect every individual unit. That is why modern factories rely heavily on automated systems. Machines can check package weight. They can monitor seals. They can identify products that fall outside specified tolerances. Some production environments also use metal detection and other inspection technologies as part of their food safety systems. Products that fail inspection can be automatically removed from the line. The remaining packages are grouped into larger bundles or cartons. Then they are prepared for transportation. From there, the journey changes completely. The noodles leave the factory floor and enter a global logistics network. Trucks, warehouses, shipping containers, distribution centers, supermarkets, convenience stores, online retailers. Eventually, one package reaches a consumer, and the entire industrial journey comes down to a few simple actions. Open, add water, wait, eat. That simplicity is precisely why instant noodles became so successful. But their history is just as interesting as their manufacturing process. The modern instant noodle story began in post-war Japan. After World War II, food shortages and long queues for affordable meals helped inspire Momofuku Ando to search for a food that could be inexpensive, easy to store, easy to transport, and quick to prepare. In 1958, he introduced chicken ramen. More than a decade later, in 1971, the company he founded introduced cup noodles, changing the format once again by placing the noodles and seasonings inside a disposable container that could be prepared simply by adding hot water. The concept was powerful because it solved several problems at once: storage, transportation, preparation, portioning, and convenience. The idea eventually spread far beyond Japan. Today, instant noodles are adapted to local tastes around the world. Different markets prefer different broths, spices, textures, levels of heat, and ingredients. Some products focus on affordability. Others compete through premium ingredients, larger portions, regional flavors, or specialized formulations. The basic industrial principle, however, remains remarkably recognizable.
Is convenience the same thing as nutrition? Not necessarily. Instant noodles can provide energy, particularly from carbohydrates, and some products contain protein, fats, vegetables, vitamins, or minerals. But nutritional quality varies significantly from one product to another. And one issue deserves particular attention: sodium. The World Health Organization currently recommends that adults consume less than 2,000 milligrams of sodium per day, equivalent to less than 5 grams of salt. WHO also notes that processed foods can be important sources of sodium. That does not mean every bowl of instant noodles should be treated as unhealthy. It means the entire diet matters. A product can be convenient without being nutritionally complete. If instant noodles are eaten, adding vegetables, eggs, lean meat, seafood, tofu, beans, or other nutrient-rich foods can make the meal more balanced. The key is variety. Instant noodles were never designed to replace every other food. They were designed to solve a problem. How do you create a hot, convenient meal that can be stored and prepared almost anywhere? And on that specific challenge, they have been extraordinarily successful. So let's go back to the beginning. A shipment of wheat flour enters a factory. Water and other ingredients are added. Machines mix everything into dough. The dough rests. Massive rollers flatten it into continuous sheets. Cutters transform those sheets into thousands of strands. Steam changes the structure. Automated systems divide the noodles into portions. Forming machines create compact noodle cakes. Drying removes moisture and creates the porous structure that allows rapid rehydration. Meanwhile, another production line may be preparing the flavor. Ingredients are cleaned, vegetables are cut, broths and sauces are cooked, liquids are filtered, flavor is concentrated, vegetables are dehydrated, seasonings are portioned. Then the two worlds meet: noodle cake, seasoning, vegetables, packaging.
sealing, inspection, carton, warehouse, store, kitchen, bowl. What looks like a 3-minute meal can therefore represent hours of processing, engineering, quality control, and logistics. And the scale makes the story even more remarkable. The latest World Instant Noodles Association figures show that demand remains enormous across the world, with more than 100 billion servings consumed globally each year. That means factories must operate with extraordinary consistency. A small variation repeated thousands or millions of times can become a major problem. A slightly different dough texture, a small change in moisture, an incorrect seasoning ratio, a weak package seal, a variation in noodle thickness. Modern production systems are designed to detect and control these differences before they become large-scale failures.
This is why instant noodle manufacturing is not simply about cooking food quickly. It is about engineering consistency. The challenge is to make millions of individual products behave in almost exactly the same way. The noodles need to cook in a predictable amount of time. They need to absorb water. The seasoning needs to dissolve. The package needs to survive transportation. The product needs to remain stable during its intended shelf life. All of this has to happen while keeping production efficient enough for a product that is often sold at a relatively low price. That balance between cost, speed, quality, safety, and convenience is what makes instant noodles such an interesting industrial product. They are cheap enough for everyday consumption, portable enough for transportation, stable enough for distribution, flexible enough to adapt to local tastes, and simple enough for almost anyone to prepare. That combination is difficult to achieve. Perhaps that is why instant noodles have survived and expanded for generations. They began as a response to a very specific historical problem. They evolved into something much larger, a global food category, a manufacturing industry, a symbol of convenience, and, for billions of servings every year, a familiar meal. The next time you tear open an instant noodle package, look at it differently. Inside that small packet is not just flour and seasoning. There is a chain of industrial engineering behind it. There are mixers turning hundreds of kilograms of ingredients into uniform dough, steel rollers transforming that dough into precise sheets, cutting systems producing thousands of consistent strands, steam chambers changing the structure, drying systems removing moisture, flavor factories concentrating broths and sauces, automated machines counting, weighing, sealing, and inspecting, and a global logistics network moving the final product from factories to kitchens around the world. All of that technology disappears the moment you pour boiling water into the bowl. 3 minutes later, it looks simple again. And perhaps that is the greatest achievement of all. The most sophisticated manufacturing processes are often the ones that make the final experience feel effortless. From a handful of basic ingredients to a finished meal in minutes, instant noodles are a powerful example of how food science, automation, packaging, and global supply chains can transform something remarkably simple into one of the world's most widely consumed convenience foods.